Hey, what's up, guys? Yeah, today I share a little bit the question that I recently found online, and I think this is interesting. And it's also related to some of my previous work. So, question is interesting. Ask about whether if ABC is all integer and they are not all zero, or they are not that they cannot be zero, and you set the max for this ABC to be 10 to the 6, and you want to show that a plus b square root of 2 plus c square root of 3 greater than 10 to the negative 21. Okay, so this question is actually interesting because we know that the irrational number can be approximated by any rational number, right? So that means that if you ask whether a plus 2, if you take a set, which is a plus b square root of 2, and then you take a b to be integer, and by the equiposition or equiposition theorem, equality distribution theorem will tell you that omega is dense in R. So basically, it says that why you can you can always, right? So basically, given epsilon, for every epsilon greater than 0, there you can always find x belongs to omega such that x is arbitrarily close to 0. Okay, but this question tells you that if you set some maximum, say some maximum bound for like each number, that you can get some strange lower bound. Although this lower bound is very small, but you can get something. Okay, so but basically it says that if you set the upper bound for your coefficient, then you can derive the lower bound of such irrational number. Okay, so let's try to prove this. Simple example. Hopefully, this simple example will give you some idea that in general how to prove in your case. Okay, so let's see. So obviously, this proof is very interesting. So you can say this is like f1, or you define f2 to be like a plus b squared root 2 plus c squared root 3. So there is some Galois type of object, right? So you can write a plus b squared root 2 minus c squared root 3, and a minus b squared root 2 minus c squared root 3. Okay, so let's see what is f1 times f2. So f1 times f2 will be a plus c squared root 3 squared minus 2b squared. And the f3, f4 will be a minus c squared root of 3 squared minus 2b squared. Right. Yeah. So you can write down. So this guy will be a squared plus 3c squared minus 2ac squared 3 minus 2b squared. And this guy will be a squared plus 3c squared minus 2ac squared 3 minus 2b squared. So if you times f1, f2, f3, f4, then you can get a squared plus 3c squared minus 2b squared minus 4a squared c squared 3. Okay, this guy is complicated. Who cares, right? But the idea is that f1, f2, f3, f4 must be integer. Okay. Okay, so obviously that we can easily find the maximum for f1, or basically for arbitrary f, right? So we can see that okay, so we have like 4 number, right? Their times is equal to z, and then we know that they're all bound by 10 to the negative 6, 10 to the 6. Okay, so that means that we can bound f1 upper bound, right? It's basically like a plus square root of b plus c square root 3 c times square root 3. So it's just you can see it's 10 to the negative 6, 1 plus square root 2 plus square root 3. So this is 1.4, 1.3 something. So it's less than 3. So it's, I can bound it by 10 to the 7. Okay, an easy proof that this 3 of them, right, is always bounded by 28. Right? But we know what? But we know that right, so your f1 is bounded by like 10 to the 7, and so your f1, f2, f3, f4 is bounded by 10 to the 28. Okay, but this guy is integer, right? That means that your f1, f2, f3, f4 is some integer, so it's greater or equal to 1 if you take absolute value. So this means that your f1 actually has lower bound, which is about 1 over f2, f3, f4. So this guy, right, this each fi is bounded by 10 to the negative 10 to the 7. So your f1 is actually greater or equal to 10 to the 28, negative 28. Okay, so you can see this translate upper bound to lower bound, and do it reverse. So it's like you use some Galois type of object that translates the irrational number to a rational number and try to apply the rational number bound to find this. So this question is actually interesting that because you can try to generate this type of proof to attack some other irrational number if you have some lower bound, got some upper bound of such coefficient. Okay, so see you guys in the next video. Hope you can subscribe to my channel.